page 169 in your textbooks. Page 169, you had numbers 9 through 11 for homework last night. And before we go over the homework, quickly want to review. There are 5 ways in which I will give you information about a triangle. I will always give you 3 things. Some combination of sides and angles. What are the 5 possible combinations I could give you? Quentin?
Side, side, side. Side, angle, side. Side, side, angle. Angle, side, angle.
Jamie, help?
Side
angle? Side, angle, angle. The only one I can't give you is angle, angle, angle. Right? I can't give you just 3 angles because 3 angles could give you an infinite number of similar triangles, right? You have to know at least one side. You could know all 3. You could know 2. You could know 1, right? Now, depending on what's given determines which law we use when. So, for the law of sines, I'll just put a little s. Which of these do we use the law of sines for, Jamie?
We use the law of sines for the SSA. The ASA. And for the SAS.
No. SAA. So it just so happened that the bottom 3 were all law of sines. The first 2 should use, class, the law of cosines. What is the law of sines, Quentin? Ooh, that's the law of cosines. What about the law of sines?
Oh, we said law of sines. I thought you said law of cosines. A over sine A equals B over sine B over C over sine C.
Good. And so anytime you know 2 angles, you can always just get the 3rd angle. How, class?
You add the other 2 together, subtract 180.
Yeah, just subtract the sum of the 2 you were given from 180. So you can always get the complete 3 angles from these 2. And then as long as you're given a side, one of these ratios is going to be complete. So you can cross multiply and solve. For side-side angle, remember there's always a matching pair. Always a matching letter, because you're given an opposite side and then one of the adjacent sides. So because of that, one of the ratios is guaranteed to be complete. The other ratio is guaranteed to be incomplete with a side, which allows you to get the matching angle, whichever it is, which allows you to get the other angle, which is why we can use law of sines for side-side angle. However, side-side angle is the weird one. This is the one we have to watch out for because sometimes we get... Well, it's called the ambiguous case because sometimes we get no triangle. Other times we could get 2 triangles, right? So here's where we actually have to compare. Remember, if the angle is obtuse or if the angle is right, what has to be true to get a triangle? Right, the opposite must be greater than adjacent. Anything other than that, it's guaranteed. Even if it's equal to, no good, we still have no triangle. The real problem is the acute. Acute is okay with opposite bigger than adjacent. Acute is also okay with opposite equal to adjacent. In fact, it almost makes it easier because you got an isosceles triangle. For acute, if opposite is less than adjacent, it doesn't necessarily mean no triangle. It means more work. Because then we have to compare what, Jamie?
Yeah, to compare the opposite to the product of the adjacent and the sine theta.
Well, I like to use the word product there. Compare the opposite to the product of the adjacent and the sine of theta. Good. And then if it's equal to, class, that perfect length, we simply get a right triangle. If it's anything bigger, we're going to get... It's bigger than that perfect length. So that means it could go in one of 2 spots. And if it's less than that magic perfect length, it doesn't quite form the triangle. Questions on the side angle. And that's really the only one that causes you any trouble at all. I mean, yes, if somehow these 2 angles added up to more than 180, okay, that would be a problem. Okay, but shy of these 2 angles added up to more than 180, these are going to give you a triangle. These are also going to give you a triangle, again, as long as they don't give you an angle bigger than 180 for some stupid reason. And as long as the 2 littles
add up to greater than
As long as the two littles add up to more than the big side, you're going to get a triangle there. By the way, the math wouldn't work there either. But, with a negative angle, like, but I can't have a negative angle. Well, that's the reason you'd end up with it. What is the law of cosines, then? Let's come all the way over here and write that. And you gave me sines, give me cosines. Two ways we could look at it. Let's start with let's start the way we normally use it. We normally use it to find angles, because that's mostly what's missing here. So give me an example of an angle and run with it.
Angle A equals the arc cosine of, in parentheses, b squared plus c squared minus a squared all over 2bc.
Good. And so finding an angle, just take the other two letters squared, add them, subtract the square of the matching letter, divide by 2, divide by the b, divide by the c, take the arc cosinus. There's your angle. Now sometimes, 1 out of every 6 times, we may actually have to use it to solve for a side. And if we solve for a side, it would only be in side angle side, that side had better go in the memory, because you're going to need it to solve for the angles in a minute. Give me the example of law of cosines to solve for a side, either A, B, or C.
B squared equals A squared plus C squared minus 2AC times cosine B.
Perfect. Remember, we'll take the square root at the end. Remember to include parentheses around here. And don't forget to hit the equals after you close the parentheses before you take the square root. Okay? Questions on all of this? All right. Now, for homework, you only practiced with the law of cosines on numbers 9, 10, and 11. They're on page 169. And, yep, I'm lazy. I don't want to walk more than one step. All right. Number 9, what did you get for your angle A? They gave you all 3 sides, so we're finding the 3 angles. Your angle A, Jamie, was?
32.
Well, that's only 2 sig figs. They've got 4, 3, or 4, so let's go 3.
32.1 degrees.
There we go, 32.1 degrees. How about angle B, Quentin?
20.7 degrees.
20.7 degrees. And here's where it's a good thing they gave us 3 sig figs to work with. Jamie?
That's 130 point.
127. My guess is you went 2 sig figs and everything. You're looking at the 130, like, oh, let's just make it a 130 point. 127, but you would have had to round it up to 130 if it were 2 sig figs. Just watch for sig figs as you work. Questions on number 9? All right, number 10. Again, all 3 sides. You're finding all 3 angles. Start with Quentin this time, angle A.
30.0 degrees.
I didn't get 30.0.
I got 30 point. Oh wait, I got 30.0.
You did. Okay, let me get my calculator. I got 29.0, oddly enough. Let's check this out. So we've got, it's side A, or angle A we're finding. So we're going to start with 60 squared, that's B squared, plus 80 squared, that's C squared, minus the A squared, which is 40 squared, divided by 2, divided by B, which is 60, divided by C, which is 80. You take the arc cosine. I got 28.955.
I got 2, but I was thinking it'd be 3 sig figs, so I bumped the 9 up to 5, right?
Right, so it is 3 sig figs. So the 5 bumps the 9 up to a 10, which bumps this up to a 9. 29.0 degrees. Does that make sense? There's a little rounding thing there. All right, questions on that? All right, let's see. We still have angle B. That should not mess up anything else, though, because angle B we can find independently. And Quentin, let's go back to you.
46.6 degrees. 46.6.
Yeah, at first I thought I heard 36.6. I'm like, surely not. Not for him to get the other digits right. 46.6 degrees is correct. And then angle C, Jamie?
Angle C, I got 104 degrees.
104 degrees is correct. And then number 11, this was the only angle side you had in your homework, so you had to find side A first, had to put it in the memory, Jamie.
4.91.
Good, 4.91, or whatever the exact value was put in the memory. That's our rounded answer for A. We needed to use that to help us find angle B, Quentin.
105 degrees.
Good. Yeah, this one's hard because you could argue 1 because of angle A, but then it's like, well, but we always have to have at least 2 sig figs. It's 104.82. I could see you saying 1.0E2 degrees if you happen to go there. You look at the sides, they both have 3 sig figs. Probably on the quiz I'd give you the 3, and 105 would be right. I actually have 105 in my book. And then angle C, Jamie?
45.
45 degrees is what it rounds to. All right, questions on that?
So we were supposed to, how many sig figs were we supposed to have?
Technically, letter of the law, you'd have to say 2 because it's either 3 or 1, but we said in this class we always have at least 2. So let's negate the 1 and go with 2. But again, I could also see, well, negate the 1, so therefore the 3s are what we roll. So I could see both ways. It's not going to be that ambiguous on a quiz. You'll know what I'm after on a quiz, but the book leaves a little room for ambiguity here. I have to use that word more often than not. All right, questions on this? Any questions at all before we take our quiz over all of this? Yesterday we felt like we were doing pretty good, so I think we're ready. So go ahead and clear your desks, except for a clean sheet of paper, a pencil, and a calculator. Sheet of paper, pencil, calculator, everything else away. First and last name at the top of your paper, along with today's date, and today is 1/14/22. 1/14/22, today's date. And this is quiz 25B. We took 25A, we'll now take 25B. Fairly straightforward. I've just got 5 triangles, kind of like the last couple of quizzes. 5 triangles. If no triangles formed, simply write no triangle. If 2 triangles are formed, make sure you solve for both. Make sure you round to sig figs carefully. Show all of your work. I'll end the video here, and we'll pick up part 2 once the students are finished with the quiz.